Okay, in this video we're going to show you how to make a sheet of graphene. You're going to make 3 of these for a later project, which is making the model of graphite. But for now we're just going to make a single sheet of graphene. The smallest number of balloons required to make a single sheet of graphene is 6. You can have as many as you want wide, as many as you want tall, but for now the simplest model of graphene uses 6 260 balloons. We're going to pump those up with 4 pumps of our red Qualitex pump. Give it a burp. Pump up our second one and give it a burp. And then we're going to tie these together to make what's called a duplet. So our 6 balloons are going to be tied together into 3 sets of 2 or 3 duplets. Once you tie these together, give it a good squeeze to soften these up. So now we have 6 balloons in sets of duplets, 3 sets of duplets. The first thing we're going to do is measure off about a 4-inch bubble. So we'll make a 4-inch bubble in one balloon. In the next set of 2, we're also going to make a 4-inch bubble. And the key to this whole project is trying to make bubbles consistently about the same size, so everything looks even and in proportion. So now we have 2 balloons together going down. We have our cross piece. On the second balloon in the second duplet, we make a 4-inch bubble. We take our third balloon, our third duplet, we're going to make another 4-inch bubble and lock twist those together. And that's our starting point. You can see now the top is in a zigzag formation, a staggered formation you would normally find in carbon-carbon bonds. We're going to leave the outermost balloons alone. We're going to start with the inside balloons, always going down vertically as pairs, horizontally as single balloons. We're going to make 4-inch bubbles and allow those ends to come off in a horizontal position. Again, the second set inside, the second set of 4-inch bubbles. Twist those around. Now you can see the beginnings of the first hexagon. In the center 2 balloons, in each one we're going to twist a 4-inch bubble and lock twist that together. That makes the first hexagon in our graphene sheet. Now we go to the outermost balloon, and with the outermost balloons, every time we encounter those, we're always going to make 3 4-inch bubbles. So here's 1, 2, and 3. To the adjacent balloon, next to the outermost balloon, we make 1 4-inch bubble and lock twist these together. This now makes our second hexagon. And as you can see, we're going to take then the other outermost bubble, 3 4-inch bubbles in the outermost balloon, followed by 1 4-inch bubble in the adjacent inner balloon. Lock twist those together. And we now have the beginning of our graphene sheet. We've now made 3 hexagons. To the balloons now going down, we're going to, and they're always in pairs going down vertically, we're going to make 4-inch bubbles, locking those in place. So it's actually 2 bubbles side by side, and the balloons going down. And again, for neatness, we want to make all these bubbles about the same size every time. So here's 1 set, here's the second set, and here's the third set coming up. You can now start to see the second row of hexagons coming into play. So the inner balloons, we're going to make 4-inch bubbles. Now you can see the second set of hexagons is about to take shape. Lock twist those into place. Now once again we have a horizontal row with outermost balloons now going off in this direction. Again, doubles in the vertical direction. The vertical balloons always get a twist together. So that's going to start off our third row. And now we can probably get just enough out of this to make one more 3 hexagon row to complete this small scale model of the graphene sheet. We'll go with the innermost balloons. We're going to make 4-inch bubbles out of those. Again, 3 4-inch bubbles in the outermost balloon, followed by a 4-inch bubble in the adjacent balloon. Now I could have actually gone to 5 pumps and gotten a little bit more out of these balloons. But now you can start to see this take shape. Again, for the last outermost balloon, we're going to make 3 4-inch bubbles. The next innermost balloon, the adjacent balloon, we make 1 4-inch bubble. And lock twist those together. And again, for the graphite model, you're going to make 2 more of these. We're going to stack these and use clear balloons for the pi interactions that hold these sheets together in graphite. But as a single layer, this is graphene. Again, you can take more balloons and extend this as wide as you want. If you want to continue on to make this longer, which you want to do for the carbon nanotube, which we'll talk about in another video, what you can do is cut off and tie the excess. You can lock twist these through the ring to make sure they're good and locked in place. And just take a pair of scissors. We're going to cut the ends to deflate the balloons. And you're simply going to tie these off. Just tie the ends and then cut off the excess balloon. So how do we continue on? I want to go further. Again, I'm just going to show you this quickly. Cut off the excess balloon, pump up 2 more black 260s, and use 5 pumps to get more actual ballooning use. Tie those into a duplet, put the duplet in to this joint, and you'll see this in greater detail once we make the large scale graphene sheet. Again, we put the duplet, the new balloons we tie in to this joint, and then just continue on and make this as long as we want. To make this wider, we just use more balloons to start with, and we can add those later, as I'll show you in a different video. When we get to the large-scale graphene sheet, which will eventually become the carbon nanotube, by rolling up the sheet and weaving together the ends of the sheet. So again, very easily, we simply deflate the excess balloon, we tie this off, and simply cut off the excess. So you can see this is becoming very symmetric. Each of the rings, because we were very careful in measuring with our hands, the bubbles are all fairly uniform, so it looks like chicken wire, like a single sheet of graphene should appear to be. Again, this last set of balloons we carefully deflate. We simply tie this off and cut off the excess balloon. You're going to make 2 more sheets exactly like this one, and then watch the video on graphite We're actually going to use clear balloons and stack these up. The clear balloons will be the pi stacking interaction that holds these sheets together to make the model of graphite, the stacked layers of individual graphene sheets. So again, very straightforward. 3 balloons is the minimum because that's what we use to make the graphite model, making 2 more of these individual layers, then using clear balloons to interlace these. In our next video, we'll show you the massive scale, the large scale graphene sheet, where we use 7 or 8 pairs of balloons, and also show you how to tie in to extend and go down. We need at least 7 or 8 pairs in a larger sheet so that we can actually roll this up. Eventually what you're going to do is roll this up and you're going to weave the ends together to make a carbon nanotube. To make that practical and fairly in scale, what we're going to do is use 7 or 8 duplets and go as wide as we can to start with, continue on down with more balloons, and then at the end I'll show you how to roll this up and weave the ends together to make a carbon nanotube. So this is the basic building block, the basic backbone for all the graphene models we're going to see today, as well as carbon nanotubes. Graphene, graphite, and carbon nanotubes. This is called a hexagonal weave. Very straightforward, so go ahead and practice this. And in the next video, we'll show you how to make graphite.